My name is Kainton the Genius, and today we are going to be solving a typical problem in hypothesis testing. So this follows from the previous tutorial where we actually decided the kind of test we are going to carry out. So we have parametric and non-parametric tests, as you can see here. We'll actually be moving up and down this page. And we've come out to decide in the previous lesson that given the particular test question we have here, the test we are going to use will be the Z test. Okay. All right. So, and the next thing we want to do is to extract the information from the question. So always try to make a sketch. This is the population and we have a sample. This is a little sample that is taken. This is population and this is sample. All right. So the next thing is to extract the information. So before you extract, also try to understand the question. In this case, it says in a population, the average IQ is 100, meaning that in this population, the mean IQ is 100. So the mean is 100 and standard deviation is 15. So so in this case, we have standard deviation. So standard deviation is represented in this way is 15. A team of scientists want to test a new medication to see if it has either positive or negative effect on intelligence or no effect at all. So this is a bit confusing, but simply say we can state it that a team of scientists want to test the fact that the average IQ on this population is 100, right? Good. So they now carry out an experiment by doing a medication and want to test whether the average IQ is actually 100. So when they do this test, they come out with a sample mean. So the sample mean they have, which is mentioned here, is 140. So whatever they come out with is simply the sample mean, right? And the number of items we have there is 30. So we have n is equal to 30 in the number of the samples, all right? So basically, this is what you need to do first, extract all the information. So let's now take the steps. Step 1, state the null and alternate hypothesis, just call it H0 and HA. So in this case, the H0 is that the average IQ or the mean IQ is 100. So that is what is already accepted. H0 is that the mean IQ of this population is 100. Once you've stated the null hypothesis, the alternate hypothesis is simply the opposite of the null hypothesis. So simply say the average IQ is not 100. Okay. This is step 1. So step 2. In step 2 now, you now state the rejection, let's state the acceptance criteria. All right, so this is very important, and for you to understand it, you must know about absolute value and critical value. So what are all of these? Now, when you are performing a statistical test, you are doing a calculation of some statistic. You are doing a calculation of some statistic T. That T you calculated is actually called the absolute value. And there is also a T existing in a table of the same thing, but in this time is called the critical value. So in hypothesis testing, you are comparing the two. So in this case, we are saying that the null hypothesis, the acceptance criteria will be when the absolute value, the acceptance criteria will be when the absolute value is less than or equal to the critical value. So take note of this, when the absolute value is less than or equal to the critical value. So this is this is our acceptance criteria. If this does not hold and we have that the absolute value is bigger, then we fail to accept, or we fail to reject the null hypothesis. So let me just clarify. The acceptance criteria is when the absolute value, the rejection criteria is when the absolute value is less than or equal to the critical value. So if this holds, if the absolute value is less than the critical value, that is the only way we are going to reject the existing hypothesis. All right, so we know that what they are doing is true. We accept the outcome of the result. All right, so now we want to state the step 3. States the level of level of significance or confidence level is not, we call it alpha, and you look it up from the table. So actually I'm just going to state the alpha. Let's just call it alpha. So alpha is gotten by looking up the table, in the table of t statistic, and I've opened the statistical table right here, and I'm going to go to t distribution, right? So if I go to t distribution, I go to 95%. Now, if you are not given any confidence interval or level, just choose 95%. So I'm just going to write it here. Confidence level is equal to 95%. So go to 95% and go to under n, which is 30. So if we go to 0.95 and we go to under n, we have 1.667. So we have 1.667. So that is this value here, as you can see. All right. So now step 4, calculate t. So actually alpha is equal to 0.95. So what we are calculating is t critical, right? So this is t critical. That is what we got from the table. So let's now calculate t absolute value of t. And the formula to do that, which you already should know, is t absolute, which is what we are trying to calculate, is equal to a sample mean minus the population mean all over standard deviation times root n. So this is the formula. So if I fix in the values I already write, we have 140 minus 100 over 15 times root 30, and that will give us 40 over 15 times root 30, and that will give us what? So let me quickly use the calculator in the system. Let's use the calculator in the system. All right, so let's start by saying root 30 is 30 root. So I'm going to multiply by 40, and I'm going to divide by 15, and that will give us 14.61. So that will give us 14.61. So in this case, we have that t absolute is not like, we check whether t absolute is less than t critical. Okay, so t absolute. So in this case, this does not hold. You can see it does not hold. Therefore, the verdict is that we reject, or we reject, although it's actually failed to accept, but let me just write it, reject the null hypothesis. So in that case, if you want to interpret it on this question, it says, did the medication have effect on intelligence? The answer is no. So we actually reject the null hypothesis. So this is how to solve a statistical problem in case of hypothesis testing, and I'm going to stop here. I'd like to thank you for viewing and also like to remind you to subscribe to my channel to get more updates. If you have any question, please leave it below in the comment box for me.